We're at day 2 of regression, and this will be similar to day 1. Again, please keep yourself muted, and we'll take breaks about every hour. We're recording just like last time, so we'll make these available as soon as we can. Post questions to the chat, and I will relay them to Neil, or we'll answer them in the chat. And we do recommend you keep your video turned off to conserve some bandwidth, and might make things a little easier to flow over the internet. And I'll hand it over to Neil.
Great, thanks, Scott. Today we're going to start back in with the slurry-fed ceramic melter data, and you'll recall that we removed the outliers, or several samples, I should say, but we're going to put those samples that are going to be outliers back in and redo our example, and you'll get a chance to see how we're going to do diagnose, identify, and perhaps do some forensics on our outliers. I want to follow through, though, is, we've got a whole group of eigen guys out there with unique skills and backgrounds who are just awesome answering the questions. And today I'm hoping we can get a little more interactive and get some of the eigen guys to unmute themselves and go ahead and make some comments, and get lots more questions from the students. I really want you folks to get this stuff. Remember, in PCA we had an X block Q residual and a T squared, so we're going to have some X block statistics, and then we're going to introduce a little bit more this idea of leverage, which is directly related to the Hotelling T squared. They're very similar types of statistics. And we'll also now talk about the studentized Y block residuals a little bit more, and how we identify outliers in all of these statistics. So what we're going to do, I'm going to switch over to the Solo browser, and we're going to redo this. Remember, we've got this slurry-fed ceramic melter, which was the temperatures. We were predicting level from temperatures. It's time series data. And so our level is the Y block, temperatures were the X block, and then we've got a test X block and a test Y block. All right, let me switch over, and I'm going to get into my browse window here. And recall that the data is over here in the demo data. I'm going to scroll down. I'm going to find the slurry-fed ceramic melter data, which is called PLS data. Slurry-fed ceramic melter PLS data. I'll highlight that. Still, just drag and drop that up into my workspace so you can see what's in there. If I look on my left-hand side under my favorites, I think you have partial least squares, and we're going to be using that one. But also under the regression section, we have PLS down here as well. So either one of those work. I'm just going to drag the X block now. I'm not going to have my test data loaded today. I'm just going to have this X block 1 and Y block 1 for the example this morning. My morning, I should say. So I dragged and dropped that onto PLS. My analysis window has started up. Now drag and drop my Y block now onto the same analysis window and drop it here as calibration Y. Okay, do I need to show that again?
Okay, might be good to make your window a little larger, Neil. Just a little hard to see.
Make my window larger?
The analysis panel, for example. Uh,
This one?
sure.
Maybe I should make I'll get a little bit bigger here. This will be about as big as I can get. How's that?
Yeah, that's much better.
Okay.
Thanks.
So remember, we went down here into the demo data and I dragged that up into my workspace. And to get things started, I took this X block 1 and dropped it onto partial least squares. And that opened up my analysis. Well, you'll notice I'll have two windows open. And what's nice about that is I really like running multiple analyses at once, but I'm just going to stick with the one I've got open. And so the Y block 1 got dragged up here as well. And it loaded its calibration. Okay. You mouse over your X, you can see what size is, 300 by 20 again. But I want to show you one of the things that we did the other day was I'm going to right click on X and I'm going to go down and say edit data. So I right clicked on that dark blue X box and I'm going to edit my data. And this is more of a how you work with this kind of a data set object. Do you recall that if I click on the row labels, I get at my samples and I can go over and I can exclude data. And we did that. We got rid of a couple of sample points on Tuesday. And if I had that still loaded up and I wanted to reset my include field, one of the things I can do is I can right click on that if I have a PC, or command click on a Macintosh, or on my Macintosh, I'm going to command click and I can clear reset my field. So let me clear that. Now that means nothing is included. And then if I do it again, clear reset, everything's re-included again. So if you had excluded data, that is one way that you could get everything back. We could also do it graphically. So that's one of the things to show you this beginning part. And also, yeah.
This is Lyle. Sorry. I just want to jump in and say that with the new version, there's a new way to, perhaps a quicker way to include things.
Oh, yeah.
I guess it won't show up anymore, Neil, but if you had stuff excluded in your data and you right-clicked on the X or Y block, there'll be an option to reset include, and you could just do it that way.
Okay, I'll exclude the first four there, just so that you can walk me through that, Lyle.
Yeah, you could do a right-click or control-click on the X block. And then there's that reset include option. And then it'll see that you have some rows that are excluded and you can just say include all rows.
Perfect.
So that's new for version 8.9.
Okay, I'm going to do that here. Include all my rows. And the nice thing about this is I really only have to edit the X block include field, because the Y block inherits the include field when we do the analysis. So the dominant here is the X block. Okay, now under pre-process, I'm going to use this button here today. So I'm going to click on the blue button and say edit pre-processing, because I know that my default is presently auto scale. I don't like auto scale for this particular problem, so I'm going to say remove. I'm going to click the remove button. And then over here On the left-hand side, I can go to my favorites, or I can go down and find mean center. Right here under scaling and centering is the mean centering. And I'm going to say add. Now I use mean centering quite often. And so I'll click on this favorite button and add that to my favorites list so that I can get at it very quickly. And that's a nice thing to do. I'll say OK. Another thing that I'll do is I go back up and click on this pre-processing button. You'll notice I have other options. I chose edit pre-processing. We can get at the basic methods. I could save a set of pre-processing and use it later, save that to my hard drive and load it back up later. I could load that pre-processing. But another one is that if I'm working on a project that has a certain type of data and I'm going to be working on that project for a long time, I can set my current pre-processing as the default. So that's one way to say, I'm not doing engineering variables anymore. I'm not going to use auto scale. I'm going to set mean centering now as my default. We can also plot the pre-processed data. And I like that quite a bit. So I'm going to say plot the pre-processed data. I'm going to put that down there. I'm also going to click on my X block, right click on it and say plot the data. So I plot the original data. And in both cases, the default plot is going to be the mean. Under data summary, let me shrink these a little bit so I can look at them simultaneously. Okay, so this is the top plot is going to be the mean of the X block. You'll notice that it goes, from about 1200 down to 400. And here's the mean of the pre-processed data. Well, the scale here is 10 to the minus 13. So essentially, my mean is 0 on the bottom one. I mean centered. So that is why we've got a mean 0 for the pre-processed data on the bottom. By clicking this plot controllers on the data button, now I'm going to plot everything that's present. And at the top, I'll do the same thing so you can see the non-pre-processed data. And this is a really nice way to compare the pre-processed and the non-pre-processed so that you can identify where the action is in the data. If I mean center, you can see it's around thermocouples 6 to 9, and over here it's 7 to 19 or something like that. Pretty clearly, we got something going on with this sample. I could click on that sample and it says row 73. So even just in this very simple plot, it's pretty easy to identify an unusual sample. I'm not going to do anything with him just yet. But I do want you to plot your data. But I also want to show you, we're going to do a color by. And in the X block, in the color by, I want to choose load from Y block. So this is the level. So I'm going to color by level, say OK, and OK. And I'll do exactly the same thing in the top plot. I'm going to say color by, load from Y block, and OK. It says use the level. If I had multiple Y's columns in here, I could color by any one of them. And I'm going to say OK. So you can see that as the level increases, there's my color bar here. As I go from blue to yellow, I'm increasing my Y block. And this is another way that you could explore your data and say, yeah, you know, look at that. This is generally blue down here and generally yellow up there, suggesting, you know, a model is potentially possible here for predicting level from my X block. But you also notice that in this region, it's very low variability, and there doesn't look like there's a trend at these thermocouples at 11 to 14 and 1 to 4. And so there is a region that we might consider excluding, but as an exploratory analysis, we're not going to do that. It also says that down here, if I look at that low signal, there's not much going on in there. This is the part that where that ill conditioning starts showing up when we start talking about, do we use MLR or do we use principal components regression or partial least squares? This is the part that might be the ill conditioning, result in ill conditioning, so that we have a harder time getting the model. Okay, any questions on that guy?
No questions in chat yet.
Okay.
For that in particular. Go ahead.
Scott. Sorry. I was just going to say, Neil, that the color by is a really powerful feature in this, and I don't know if you will probably do it at some later point, but if you click on the color by, there are a lot of different options for what you choose to color, the source of your color, and like you can load another data set, for example, for a vector of y, for example. But once you have built a model like with PCA or PLS, once you've built the model, you'll see that from scores plot is shown there, and so that's actually a really nice way that you can color your data by, for example, the first principal component or the first latent variable scores. That's something that I've just been using a bit lately, and it's really nice.
Yeah, it does help with interpretation for sure.
So yeah, take a close look at the various sources of the coloring data. That's all I wanted to say on that.
And don't forget that in your dataset object, if you have labels, you can click this button here, and your labels show up so that you know who's who. So it's another aid in helping, and you can grab those things and move them around so you can see a little bit better. You can change the label angle as well. So under the view, I changed my label angle 90 degrees. Okay, plotting our data. Let's see the last one here. Maybe I should also plot versus columns. And I can do a shift and plot them all. And get rid of my color by saying none and say okay. And we can do the same thing with our pre-processed data. Plot columns. I'm going to get rid of my color by. None on the color by. And I can hold my shift key and we can look at the centered data. You can see here's 0. So the pre-processed data origin is 0. And remember that if we mean center, we're going to allow for an offset in our model. Again, this particular sample is very easy to identify as an outlier. The same one that's up here. Oops. Oh. Oh no, that's my Macintosh.
Just hit the home button.
Yeah. My home button doesn't do much.
Oh, hit the plot button in the plot controls.
I get lazy fingers over here, and I will just have to plot my preprocessed data again. Plot columns, and that, what I mean is by lazy fingers is I brush my mouse and it wants to take off and go someplace else. Okay, so plotting your data is one of the first things that we do to identify what we might expect in our data. We like to plot the original data up here, and we compare it to our pre-processed data that we plotted in the bottom down here. So let me get to the summary. So the bottom temperatures were higher than the top temperatures. We saw that from the original data. And the surface in plenum space is cooler than the bottom. And we saw our sawtooth pattern, and we're trying to identify, is there some signal that might allow us to get a model, get our regression model X versus Y. We also talked about, which analysis we want to use. Well, I dragged and dropped onto PLS, so I'm already going to do principal components analysis, or I'm sorry, partial least squares analysis here. So for today, we're going to do that. If you don't have that one, you can get it from the analysis window by clicking under the menu analysis and going to partial least squares. We talked about auto scaling being the default. I switched to mean center, but I also changed mean center to be my default for the X block. I need to do that also for the Y block. So if I come back over here, my Y block says auto scale. I don't want that one. I'm going to say edit my pre-processing, and because I'm doing a basic method, the quickest way is to go to mean center. But let me show you another thing here. So I made a plot of the pre-processed data, but from the pre-processing window itself, I'm going to click again on this P for the X block. So the pre-processing for the X block, and edit pre-processing. My window for pre-processing comes up. I've got mean center shown here. I can come down also at the very bottom left. There's a button called Show. I'm going to click that, and it brings up the window. It's a little less flexible, but it does show me my raw data on the left-hand side and the pre-processed data on the right-hand side. We can view classes if we had classes available, and we could view excluded as well if we had excluded data points. It's a little less flexible, but it's a very quick way to get a good sense of what the pre-processing is doing to your data. And I can cancel or say OK. So now mouse over, I've got mean centering on X and mean centering on Y. And we're getting close to getting our model going. Again, though, we have to remember that we like cross-validation. That's this red checkbox. You can see my cross-validation method is none. I'm going to click on this box and change that. So I clicked on the red checkbox over here to get the cross-validation window up. We have time series data. So I'm going to choose contiguous block. I have 300 points, and what's the square root of 300? I don't know off the top of my head, but I'm going to do a split of 10 splits for my data set. One of the things about this cross-validation is you can see in a little schematic up above how the data is going to be split into those 10 blocks. So they're colored by the different cross-validation subsets. I need to apply this, so I click apply. And I'm going to close my window just to keep my desktop as clean as I can. Okay, so close. Now I'm ready to run. I built my model. I've got a sum of squared captured information down the bottom. I go to edit options. Is that where I want it? No, tools. I want to view my cache by lineage. That's what I really want to do. No cache data. So under edit, I've turned my model cache off yesterday because I was doing some analysis after course. So I'm going to change my model cache settings to turn my model cache back on. Right here, to on, and save that. This is one of the things I'll do often because I deal with some really big data sets. Like, for example, doing hyperspectral imaging, I've got data sets that are gigabytes of size. And so I'll go in and turn my model cache off so that I don't use up my hard drive and take all the time saving. But with smaller data sets like this, having the cache on is a pretty nice thing to do so that I have my models available to me. And what that means is I'm going to build a model over here. Wow, look at that. I've got lots of stuff in my cache. I'm going to build another model over here just by simply double clicking on the 3. You'll notice that my cache has updated. Let's see if I can find my cache by date. There's October 1. There's the model I just built. This is useful for cases, for example, I'm going to do a lot of exploration and I had a model that was really, really good and I want to get back to it. Well, it's saved to my hard drive, so I can go find this thing. So that's where that is, just in case you want to utilize that tool. I'll leave that on for now. But as we are starting, we're pretending like we just started with this data set. We've got all of the data, all 300 points in. We haven't excluded anything. The next step here is to look at the eigenvalue distribution and our cross-validation results. So under this button up here, the lambda button, I'm going to access my ARM-SECV and ARM-SEC. I'll click on that curve, and it highlights the label. I'll hold my shift command, or I think it's control click for PCs to get both my labels on the plot. And I can also put a legend on so I know who's who. Now the question I've got for the students is, how many latent variables does this look like we should be keeping? If I look at my ARM-SECV, it looks like I've got a global minimum at about 5 factors there. My cross-validate, or my calibration error, is quite a bit lower at 0.017 versus 0.117. That's significantly lower. It says to me that maybe 5 is too many. Maybe really what I ought to be doing is looking at 2 or 3 or even 4 and 5. They still have the same armor. So this really looks like I might be overfitting a little bit. But I do have a couple of things here that are suggesting a potential problem in that I didn't improve every time I added a latent variable. So right now, in our exploratory analysis, we're looking at the data. I'm going to click on the left-hand side. I'm going to choose 5 for now. So now I've constructed a 5 latent variable model. And notice I've got a new model up here. And we're going to look at our scores plots. The Erlenmeyer flask. My default plot comes up with these 4 plots. And I'm going to make that a little bit bigger. But one of the things I also want to point out is that under, I think it's view here, settings. Let me take a quick look to make sure. Nope, that's not the one I wanted. Analysis, options. There we go. Sometimes it's hard to find all these things, even for people who work with this stuff often. So under the analysis window, edit options, default plots. I can change what my default plots are. So you might not like the ones that come up automatically, and you can change those things. But you'll notice here, I've got Q versus T squared, PC, 2 versus 1, cross-validated predicted versus measured, and I've got my residuals versus leverage. You can change all those things for whatever project you're working on that might be appropriate to you. I'm going to cancel and keep the ones that I've got. But that is a very nice option for you. Okay, here's my default plot. Here's my Q residual versus hoteling T squared. Now remember, this is a reduced number, means that I'm going to ratio to the probability that I have as my default. And in my plot controllers, my confidence limit is set at 95, and so that's what my reduced statistic is going to be ratioed to. So value 1 corresponds to 95% limit line. So under the hoteling T squared and the Q plot, I see a couple of points sticking out here that are unusual. Hoteling T squared directly related to leverage. Well, the truth is leverage has an offset term in it. And if you have the offset term, you would make a plot of leverage versus hoteling T squared. You'd see an intercept that was not 0. A lot of statistical software packages ignore the offset in the leverage term because the important part is in the other term that is directly related to the hoteling T squared, and they're scaled. I'll show you that by making a separate plot. I'm going to double click this top left plot, and I'm going to change the Y, what's being plotted on the Y side of this, to be the studentized leverage. Okay. Where's my studentized leverage? Or I'm sorry, just the leverage, not studentized leverage. So you can see that this is making a line. So the leverage is directly related to the hoteling T squared. They're just scaled. It's just a slope difference on it. But the leverage is one of the things that people really look at often, and they'll use that one instead of the hoteling T squared, even though they're giving essentially the same information. So I've got a point in my leverage that's really high over here, and I've got a point over here It looks like he's really high on my hoteling t-squared. Well, let's select that point by using this button, the selector button. It says, if I mouse over, it says make selection. Click on that and draw a box. Select that particular point. Our plots are linked, so the one I select over here shows up in every other box. And it makes sense that that point is high on leverage because, as I showed you, they're directly related. It also shows up in the t-squared, or I'm sorry, the scores plot, which makes sense because our leverage and our hoteling t-squared are being calculated from our scores. I can put a number on that point so I know who's who, view numbers on and off. And it might not be any surprise that that's the one that we saw earlier when we were just making plots of our data, that's the most unusual sample. Or looked unusual just by eye, whereas now he's sticking out like a sore thumb. He's high both in Q and in t-squared. And we can also do a plot. Let me double click this guy again, of just the t-squared versus sample number. And this is a real typical plot. I'm going to move them down to the left-hand side. So I've plotted hoteling t-squared on the y for this plot versus sample number. I created a new plot by simply duplicating this one, and I did that by double-clicking in the white space. You'll notice that I've got a couple of points out on hoteling t-squared here. So I'm going to select with my box again on the left-hand side. I'm going to hold the shift key down now, shift, and what that's going to do, it's going to allow me to retain the selected point that I had before and now highlight a couple of more points, and we'll see those in all of our other plots. Again, the plots are linked so that what I select in one shows up in the other. In one of the original sets of slides, from way back when, we've been teaching this particular course for a while, sample point number 100 was also excluded. And we kept that in our original analysis, but we did exclude this point and this point, 278 and 73. But you can see why number 100 might be excluded, because he looks a little unusual here in my t-squared versus q. Looks unusual in the leverage. And he's right on the edge here of this particular scores plot. But he's not crazy out there like 278, especially number 73. This plot on the bottom left, I'm going to switch now. And we're going to look at the Q residual. Now remember, if I have a plot open and I have an active plot open, I can click on the inside of it and it brings the plot controller to be relevant for that particular plot. So it makes sense that we've got a low Q on this plot and in this figure. We've got a low Q for number 100 down here, and number 278 and 73 are still out. Any questions over there, guys?
No, nothing yet.
Okay, cool.
I will point out, Bob mentioned on a chat I had with him that you can zoom in to this screen in WebEx. For me, if I click the View menu in WebEx, and then I can see there's a zoom in and zoom out functionality though. So if you're having difficulty seeing any of the plots or any of the labels in the plots, you can zoom in to get a better look at them.
Okay. Another thing that we're going to look at, and I'll keep this plot open over here and modify him, is I want to make my predicted level versus my measured level. So this is the calibration performance plot. 278 has a high studentized residual, and 278 is a ways off of the fit line. The green 1-1 fit is our perfect prediction. The fit, which is essentially the predictions being modeled as a y equals mx plus b kind of a thing, is an indication of maybe there's a bias in there, like we'll have an offset or a different slope. And so we do see a slight bias in our performance compared to the fit line. But you'll notice that 73 is way the heck out here. And we're going to play with him a little bit shortly. Seeing that these are potential outliers, and I've got something that has a high t-squared, if you will, for 73, why am I able to get a good prediction for number 73? Well, it may be that the model, its leverage, number 73, has such a high leverage and a low residual. It may be that he has had such an influence that the model has been rotated. Its latent variables have been rotated over to capture that particular point. And that's the indication, or the comment that we made earlier, is that sometimes outliers can have a pretty big influence on your regression model. And what we're really wanting to do on this model is we want to capture the general trend. We're not trying to get after individual points. We're not trying to fit him so much, but we would like to be able to identify that he's present, i.e., do we trust the regression prediction on this one? It's got a high Q residual. We've mentioned earlier that if you have a high Q, you can't trust your predictions. Well, here we have a reference value available to us. So we know, for example, it looks like he's predicting well here and here. These are consistent plots. In the future, I wouldn't necessarily have a reference value available to me. That means that if 73 came in with a high Q, the prediction for him might be biased, but we don't know from what we're looking at, just by looking at a 73 prediction. But looking at 73 with high Q, we would say, nope, don't trust that one. It's a no call. So it's okay to say, I have a no call. That's actually really important information. On the left-hand side here, I can right-click or control-click with a Mac and get my statistics and say show on figure. So I've got my cross-validation and my calibration aren't too far off, but it looks like a value of 0.01, which we thought was pretty big in my cross-validated results. That's where we have a 5 latent variable model. One of the things here is I've got my predicted versus my Y measured. So this is a plot of the fit of the data, not the estimate of the prediction. What I'd like to see people doing more often is, instead of showing the predicted or the fit, is to show the cross-validated predictions. Okay. Oh, he didn't update. This is my... Uh-oh, I'm a little bit locked up here. I think WebEx has got me slowed down. There we go. Now we've updated. This is my cross-validated predicted, and this is a much better representation of how we might expect our model to perform in the future compared to fit. Now, I know that people want to walk in and show their boss a really good fit plot, but this is the way that we're not going to make people overly optimistic on what we expect our performance to be. Okay. So I like the cross-validated predicted. We could also look to see, are we making a prediction based on the earliest latent variables? And that's a good thing. I can plot my scores on latent variable 1 on the X block and my cross-validated predicted on the Y. It's really nice to have the relevant information come into the earlier latent variables rather than the later ones. Because if they come in the later ones, you have to fight a little bit harder to get the relevant information up. And we do that with pre-processing type techniques. Okay, so let's try something else here. So I'm going to build a model on 3 latent variables. Just by double-clicking on the 3 over here, I now have a 3 latent variable model. And you'll notice that 278 that was down here has now moved up in Q. Why is that? Well, our model was being had a much larger subspace, if you will, when we had 5 latent variables, and the model likely bent over to try to capture 278 because he had an influence on our decomposition, our PLS decomposition to get the basis. And now that I've reduced the number of latent variables, number 278 has a higher Q because the variance for that particular sample has to go somewhere. I now have another point that's out here, so I can click on my selector button, hold the shift key down, draw a box around him. Another point, 172. Okay, any questions or comments back there?
Oh, nothing yet.
Okay, good. Over here, I want to select this particular point, examine who that one is. It's number 167. And the question I would have is does he have a high residual, and should it be excluded from the sampling or from our modeling effort? Maybe. You have 3 standard deviations essentially. We've studentized our leverage. That means that everything's supposed to lie approximately between -2 and 2. So in this particular range, we've got a confidence limit line being drawn here, and he's outside of it. Well, maybe you don't get rid of him because he's really close and you expect to have something outside of this confidence limit line. And maybe you do. And what happens here is when we do exploratory analysis, we don't start getting crazy and start excluding everything really fast. Instead, what we do is we go slowly and do them one at a time and explore our model. So I want to show you a mistake that you might make so that you know not to do it. I'm going to turn off my selection. This button here says deselect all. And you'll notice I have my numbers turned on. I want to show you what happens if you deselect all, because right now only the selected ones have numbers on them. If I click the deselect all, you're going to get numbers on everything. It turns into a mess. So that tip says turn off your numbers, your view numbers on and off before you deselect all. Now I'm going to select again. I just want to select this particular sample point, number 73, the most egregious outlier, and I want to exclude him. If I right click on number 73, oops, it says remove label. All right, well, turn this off and then right click on it. I can exclude the selection. Previously, we showed you other ways where you could include all or exclude all. This kind of a way to exclude this selection is available to me just by right clicking, but also under the plot controls edit, I could say exclude selection or include all, include selection, only selection. Well, I'm not going to include just that particular point, but I can exclude that selection. So there's lots of different ways to edit your data and edit graphically. Let's exclude number 73 and rebuild our model. We get a little tip. Gives you a little extra information about what you're doing. And that's typically showing up when you are running a session for the first time. Okay, got my numbers on down at the bottom. I'm going to build my model again. And I want to look at now my RMSE-CV plot. So up here in the plot controls, I can also find, oops, I closed that particular window. I want to look at my cross-validation. Remember what it looked like before? Is it looked like I should have a 5-factor model was the minimum. Now, without 73 in there, it's saying I need just a 4-factor model. So the latent variable that we had with 5 was trying to describe essentially just number 73. I double-clicked on this left-hand side to make a 4 latent variable model. My cache is updated. I'm going to close my cache window so that I have a little more real estate here. And then now I can come over and look at these sample points here. Who do you think this one is? Remember what you saw before. Putting my selector on, and I'm going to put my numbers on. Number 278 has a high leverage. So then you'd say, you know, I've got some more samples I want to look at. I've got another high Q here. I click on my selector, and zoom in, and I see number 270 there. Over here, I'm going to select these points. .278 and 279. Number 100 is one that we might consider getting rid of again. But remember this one, and I really like, Barry, you're online. I like the comment that you made about this one is if you see number 278 being out, and you know that this is time series, number 279, we could probably justify throwing out because it looks like whatever affected this point is still affecting number 279. I can also click on View Excluded here. And that's this button. Number 273, or number 73 is the only one excluded. But let's see where he lies on this plot by clicking that. Way out here. He's got a good prediction. He's got low residuals, but he's still way out here. It looks like he's getting further away. We dropped a latent variable. We dropped one of our vectors that describe the subspace for X. So it's not too surprising that 73 is moving further away because the fifth latent variable that we used to have was being used to describe them. What types of diagnostics do we have here? Back at the plot controllers, I have something called QCon. This is the Q contribution, or it's a row of the E matrix, the residuals matrix. If I click on QCon, I can go and select number 73, and I get a contribution plot. This is that residuals plot. Okay, I'm going to close this window so I don't have to update all the time. So these are the residuals for sample 73. He's got a high residual relative to the cap, number 20 and number 19. And over here on the left-hand side, it's low on number 10 versus number 9. Here we're high on number 20 versus number 9. Well, remember when we made that plot of the original data, I'll go make the plot of the original data. I'll make a plot of all the data. Oops, I'm not plotting number 73. I'm going to plot my rows because I really want to see number 73. And we can come all the way down and plot number 73, who's excluded, and compare them to the points around them. If I put my legend on, might be going a little bit too fast right now, but you'll notice that number 73 is low on 10 versus number 9, and we have our residual over here is low on number 10 versus 9. Because this is being plotted on a subspace, it's going to be the x hat minus x. Number 20 doesn't really look all that bad over here, but projected onto our subspace, it does have this difference there. So it should be, you know, what the yellow one is and what the blue one is, but this one's low here on number 10, and it's not low here on number 20. It's another thing you can do here. Back in the analysis window is I can plot the x hat. This is our estimate. So I can look at the reconstruction. I can look at the residuals. This is the QCon again. And I can plot the original data. I'm going to check those two and say, okay. Now I want to plot my rows again. There's 73. I come down here, and now here's my fit data and number 73. So this, now you can start seeing why these two plots, or why the plot on the left looks the way it does, is here's my fit. The measured is the blue, and the fit is the red one. So you can see how I have a high residual on number 9 and a low residual on number 10. You can see why I have a low residual or a high residual on this one, 73 minus my fit, and a low residual on this one. These are the types of forensics and diagnostics that you do to identify not just the outliers, but why they're outliers. We're trying to learn something about our data. How are we doing on questions over there, guys?
It's still pretty quiet. We're at an hour right now. It's 8 o'clock.
Okay, so we can take a quick break and then we'll come back and talk about how we calculate some of these statistics. And hopefully we'll have some questions. So